Hi everyone, and welcome to lesson 18.1, starting on page 237. And today we are going to talk about graphing the parent functions of our reciprocal trig functions, as well as tangent and cotangent. So on page 237, we see the graph, or talking about f of x equals cosecant of x. And the relationship between the cosecant function and the sine function is that they are reciprocals of each other, right? So we know that 1 over sine of x is our cosecant of x, right? They're reciprocals of each other, and vice versa. 1 over cosecant equals sine, which means that their values are going to have a relationship to each other as well as their graphs, right? So sine of x around at these values, right? We have 0, square root of 2 over 2, 1, square root of 2 over 2, 0, negative square root of 2 over 2, negative 1, negative square root of 2 over 2, 2, and finally 0, right? And again, these are just found by looking at those y values around the unit circle, because again, we're relating this to the y. Now, just a reminder, anywhere you see the square root of 2 over 2, that's approximately 0.707. Now, cosecant, on the other hand, is that if we're doing 0 divided by 1, now we're doing 1 divided by 0, so this is undefined. And then the reciprocal of square root of 2 over 2 is 2 square root 2 over 2, which is just the square root of 2, which is approximately 1.4, which we'll need a little bit later. Reciprocal of 1 is 1, and then again we have square root of 2, undefined, negative square root of 2, negative 1, and then as we move down, negative square root of 2, and undefined. Okay. Now as we plot the points then for sine, okay, we know our sine graph looks a little something like this, right? We've been talking for a few days now all about our graph of sine and how to graph that parent function there, right? Or if we move back to the left again, that periodic nature we have as well. Well, what's happening then with the cosecants, if we were to plot those points, again, at 0, cosecant is undefined. So we got this kind of vertical asymptote thing happening. And then we said that the square root of 2 is about 1.4. So we'd be up here at 1.4. And then we'd be at 1. And then we'd be back at square root of 2, which was 1.4. And then we had another undefined point. So it looks something like this, right? And then over here, we had negative square root of 2, so negative 1.4. And then we had negative 1, negative 1.4, and then at 2 pi, we were undefined again. So essentially what we are seeing is a bunch of parabolas within our vertical asymptotes, and the vertical asymptotes are basically occurring where our graph is touching 0, right, or our midline. Okay, so if we notice here, again, the vertical asymptotes are occurring at the midline, right, where x is at the midline. And basically what we see here is that relationship is anytime we kind of have a max or a min in our sine graph, we kind of see that parabola for our cosecant graph, okay? Now some facts about the graph of cosecant. The period is still 2 pi, okay, because notice we have one upward facing and one downward facing kind of parabola before back to an upward facing parabola within 2 pi units. We have a vertical asymptote occurring every time we are at 0, 1 pi, 2 pi, 3 pi, aka k times pi. And basically we're saying that k is any integer. Okay, so again, that's kind of relating back to the idea that it was occurring at 0, pi, 2 pi was where all of these were occurring. Okay, and going both directions on that way, negative to positive infinity. Okay. Our domain then is essentially anywhere as long as it's not equaling that those 0 values, right, where the vertical asymptotes are occurring. And unlike sine and cosine, where we have the max and the min, notice officially we have our range is pretty good to go because of the infinity aspect of this, but anywhere inside of this range here is where we did not see any values on our graph. So what that means is that really the range here is from negative infinity to -1, include that, or +1 to positive infinity. Okay, kind of anywhere between -1 and 1 isn't going to work. Okay. There aren't any zeros because it's undefined anywhere where you were touching 0 here. And intervals in which this was increasing, kind of, you have a lot of options here, but from pi over 2 to pi, it was increasing. And then officially, like if you're moving left to right, then from pi to 3 pi over 2 also worked. Those are some increasing intervals. Decreasing intervals, again, are as you're moving left to right where it's going negative. So officially it was going negative from here to here, left to right. Officially from here to here, left to right, we're going negative. So those would be some intervals in which it's decreasing, okay? And we'd represent those with union symbols. Now, moving on from there, on the next page, we want to talk about our secant graphs. Now, secant graphs relate to our pal cosine, right? 1 over cosine of x is going to be our reciprocal function secant. So kind of like the last graph, let's look at this by starting by graphing our lovely parent function of cosine, because secant goes with cosine. And so if we look at this parent function here, and again, kind of continuing on beyond one period, just so we could see this a little bit better, right? What we notice is that, again, wherever this graph touches 0, we are going to have an undefined point when we look at its reciprocal. So basically, you can draw in anywhere your graph is touching the midline at 0, we're going to have a vertical asymptote. And then anywhere we have a max or a min, again, these max points or min points of cosine will lead to kind of the vertex of these parabola pieces. Okay, and there is our parent graph of secant. Now, again, the vertical asymptotes occur at your midline, okay, whenever we're touching that, or in this case, aka 0, or the x-axis. And again, most of the information here is kind of the same as the last in that it's going to have a period of 2 pi, and then the domain, we'll talk about in a second. The range, again, from negative infinity to -1, or 1 to positive infinity. Again, there are no zeros because we have those undefined points. And then we have these different increasing, decreasing intervals based on, okay, we're decreasing because as we move left to right, we're going down. But we're increasing, for instance, from 0 to pi over 2 because as we move left to right, we'd be going up, okay? Here to here, left to right, we're going up. Left to right, we're going down. So you have different increasing versus decreasing. This time, though, our vertical asymptotes, again, are not where it's at 0 pi, 2 pi like it was last time. It's at kind of the pi over 2 halves, if you will. So, for instance, here was 1, so pi over 2, 3 pi over 2, 5 pi over 2, all that fun stuff. So the vertical asymptotes then, this first one here, is at 2k plus 1. This is kind of for an odd value, that fractional value, and then pi over 2. Right, and again, this is just, k just means it's any integer. And then again, anywhere the vertical asymptotes are occurring, that's where your domain cannot occur because we are going to have undefined points there. Okay. Now, the main thing you really need to know out of these two is that that period is 2 pi of these parent functions, and again, that our vertical asymptotes are occurring where we have hit the midline. Those are kind of the two big things you need to know about our two parent functions of cosecant and secant. Now with tangent, okay, if we calculate some values on our unit circle, if we think about tangent of 0, we are at 0. Tangent of pi over 4 is 1, okay? And then we have like, once we get to tangent of pi over 2, though, it's undefined. Tangent of 3 pi over 4 is -1. Tangent of pi is 0. Tangent of 5 pi over 4 is +1. Tangent of 3 pi over 2 is a vertical asymptote, okay? So what we're seeing is, again, kind of this pattern continuing onward, okay? Or over here, we have this as we move left as well, okay? So what's happening with tangent is tangent kind of has this little curve to it, if you will. It's got this little curve up and down, right? And it's got, the important thing to note with tangent is it has that value at the origin of 0, 0, okay? So this is our tangent graph, parent function. Now, tangent, notice, is special, if you look on page 239, compared to our other graphs, because it repeats more often. From pi over 2, negative pi over 2 to pi over 2, that's 1 pi. Pi over 2 to 3 pi over 2, that's only 1 pi. So that's really special about our tangent graphs, is that their period's a little bit different, okay? Now, overall, though, the rest of this, again, you're going to notice we have vertical asymptotes occurring at those odd values. So when it's 2k plus 1 pi over 2, and then, again, the x cannot equal that. Range here, all real numbers, from negative infinity to positive infinity. Because notice we're going from negative infinity up to positive infinity. Eventually, every y value is accounted for. And then basically what's happening too, we have zeros at pi, 2 pi, 3 pi, 0, negative pi, all that. So kind of those pi over k values. And we are always increasing. We are never decreasing in these. Because as we move left to right, we're always increasing, right? We're always going up on these. Okay? So it's never decreasing. Cotangent, on the other hand, is going to be a little bit flipped around, because this time, if I try to take the cotangent of 0, I'm getting an undefined value. Cotangent, of pi over 4 is 1. And then we have cotangent of pi over 2 is 0. 3 pi over 4 is -1. And then we have a vertical asymptote. And then we see this pattern, again, continuing onward. So essentially, it's kind of almost like a reflection, if you will, little translation of our tangent graph. And the big thing here is that this guy is always decreasing. And again, the vertical asymptotes are a little bit different than where we see them otherwise located, right? It's a little shifted over, because before our vertical asymptotes were at negative pi over 2 and pi over 2. This time we are starting at 0, okay? Period, again, is very special for tangent and cotangent. It is pi. And again, this time our vertical asymptotes are occurring at the pi values, not the pi over 2, 3 pi over 2, not the fractional values, okay? And again, this time we're always, always decreasing each time. Okay, so when in doubt, take the tangent of 0 or the cotangent of 0 to remember, is it a 0 at 0 or is it a vertical asymptote at 0? That'll help you figure out, is this a tangent graph or a cotangent graph, okay? Now, that's the main ideas of this, is kind of understanding that basic parent function values of these. Just as a side note, though, when we're looking about odd or even, if we check out all of these graphs except for our value of cosecant here, okay? Secant, which is on the next page. But all the rest of these, if we turn our graphs upside down, all right, what we notice about these is that they have symmetry to the origin, because, for instance, with the tangents and the cotangents, if you were to take this and turn it upside down, these graphs would look exactly the same. And same thing with cosecant. If you turn this upside down, it's going to look exactly the same. The only even function then is our secant graph, because when we fold this over the y-axis, we would notice that it's the exact same graph. It's got that reflection over the y-axis. So for this last part, when they're asking which one's odd, which one's even, the only one that's going to be even is secant because it's symmetric to the y-axis. All the rest of these are going to be considered odd because they're symmetric to the origin. AKA, you can flip it upside down and it looks the same, right? And then same thing for cosecant. Okay. All right, thanks everyone. We will definitely be working more with these in class, and especially tomorrow with transformations of them. Thanks.